Alright, so this video is going to be on kind of the general, it's 6.4 in one of my textbooks, but it's the general approach to factoring. Kind of like an overview. So we learned all these ways of factoring, but how do they relate to each other? How do you just look at something and know how to factor it? So I made a little, where'd it go, flow chart that kind of goes over our general, all the different things of factoring. And so I'm going to put that on here and show you kind of the idea. So here's where it starts. Oops, let's see here. So we always start with GCF. Are there any common factors? If so, you have to take them out. If not, you still move on. You always have to check that GCF first. It might keep you from doing your difference of squares, your cubes, it might make the problem way easier where you don't have the number in front of the trinomial, the number bigger than 1 on A, like a 2 or a 3 or something. And then how many terms do you have? That's where you go next. If you have 2 terms, you go this way, 3 terms or 4 terms. Well, let's talk about 2 terms. We have on the 2 terms, we've already done the GCF, we have 2 things. It's either a difference of sums or a difference of, well, basically, do you add or subtract in between the 2 binomials? If it's an add, it has to be a cubic or it's prime. Okay? So it's either a cubic, or you can see this goes down to how to do the cubic here. So you're either prime if you have add and 2 binomials and you've already done the GCF, or you're the cubic that we just went over in the last section. Or if you have 2 terms and you're a difference, you could be the difference of squares. So that one again looks like this, where they're the same thing in the parentheses, opposite signs. Or you're no, and you could be a difference of cubes. Okay, if you're a difference of cubes, great, then you got to break it up using your formula. If not, nope, you're prime. So binomials have 3 options. They could be a sum of cubes, they could be a difference of squares, or a difference of cubes. That's it. Otherwise it's prime. So those are the only options if you start with a binomial. Trinomials are a lot harder. So let's look at 4 terms first. We have one method, by grouping. That's it. We haven't done anything with 5 terms yet, or 6 or 7, so 4 terms is it. That's the only method. If you have 3 terms, is it a quadratic? Well, that's kind of, I found this one. I don't know if I like, is it a quadratic part? So trinomials, it's going to either have a leading coefficient of 1, so basically I'm kind of taking that part off. So it's either going to have a leading coefficient of 1, or it's going to have a number in front of x squared, or a larger leading coefficient. Goodness gracious, this one kind of does it weird. Oh, okay, now I get where it's going. So is it a quadratic? Coefficient of 1, it goes to, all right, well, we know it's going to be x and x, right? And then you have to come up with the other numbers by, all right, what multiplies to the n number and subtracts or adds to the middle number, kind of like we did. So these ones are easier trinomials. If it has a number in front of x squared that's bigger, then we would go this way, and we would either see if it's a difference of squares. So meaning, like, if you have 4x squared here and over here you have 81, and the middle happens to be like 18 or something like that, then we can actually look at that, and it might go into this special case here. The reason why I never bring this one up, and why it confused me, this one falls into this same category as well. You just have to watch out how you write the answer. So I don't usually do that one much as a special thing. But you know, it can work out if these 2 are squared and it's 2 times whatever the 2 squares are in the middle, then it's factorable this way. So you don't really have to know that, like, anything special for this, because you're going to find it in here or in here. So if you have a number in front of x squared, or a is larger than 1, then what we did was we did that AC method. So we took a times c, and then we figured out what multiplied to give us the a times c that added or subtracted to the middle. Then we broke up the middle term, and then we factored by grouping. Okay, so that's the general idea of factoring. You have to decide, does it have 2 terms, 3 terms, 4 terms, and from there you can work down. And all I did was, this is factoring flowchart. I just Googled it. And I have probably a different one every time because I've Googled it many times. Okay, so let's try a couple factoring ones that are harder from the textbook. So here's my first example. What if I have x to the 16th minus 1? Okay, so this is 2 terms, so we have to decide, is it a square or a cube on the difference, or is it prime? Well, it is a square because square root of 1 is 1, and we can take half of 16. Basically, it's even. So we can break this up into half, which is 8, and plus and minus 1. And that would get us back to our original. What is confusing about this one is you can keep going, because this one we're done, because once you hit the plus with an 8 power, it's not a cube, so we're actually done with the 8 side. But this one is still a difference of cubes, because 1 times 1 is still 1, and you can take half of 8. So we can split this one up again into x to the 4th minus 1 and x to the 4th plus 1, and still bring down this one here. So we got that one. Now look again, here's our 3 factors. These 2 have plus, so we're done. They can't go any further because they're not a cubic, and when they're plus in a square, we're done. But this one can go down further, so we can break that one into x squared minus 1 and x squared plus 1, and then you bring down the other 2 terms. All right, still not done. 4 factors. These 3 have plus, no cubes, done. But this one can go into x minus 1, x plus 1, and then you have all those other ones. Holy moly. So sometimes you can keep going. Hopefully not that many, but this was straight from one of my textbooks. I was like, wow, that's a lot of factors. So you end up with 1, 2, 3, 4, 5 factors. Ugly. Okay, let's look at one that's even uglier. And this is my last example. So what if I have x minus y to the 3rd minus 27 minus y to the 3rd? Okay, these are both cubics. There's our x, there's our y for our formula. Remember, the cubic says x to the 3rd minus y to the 3rd is equal to x minus y times x squared minus, plus xy plus y squared. So what we do is we figure out what x and y are, and then we put them into the formula. Well, x is x minus y, and y is 27 minus y, so it's actually super duper ugly. So let's plug in those. We know that x is going to equal x minus y, and we know that y is going to equal 27 minus y. And put in them as a parenthesis. This has to go here, here, and here, and this one goes here, here, and there. So we'll go x, which is x minus y, minus y, 27 minus y. Okay, there's our little parenthesis. Big parenthesis. X squared, x minus y squared, plus them times each other, x minus y, x 27 minus y. And I gotta move my paper over so we can't even see the other part anymore, plus y squared, 27 minus y squared. All, parenthesis around that whole thing. Holy moly. This is the answer, except you have to simplify it. That's super ugly. So, I don't know, some of them might just make you do it this way. They may not make you actually simplify it further. But here you would distribute, add your like terms, so this side wouldn't be too hard. This side you have to multiply this out. So think of it as x minus y times x minus y. You'd get 3 answers here, 3 answers here, 3 answers here. And then you would have to combine all your like terms. So long story short, This would keep going for a long time and it would be a very long problem. But that's kind of the idea of it, and I wanted to show that. All right, so there's the general approach. Always check your GCF first.